Charles's law. So the first one, Boyle's law. So when the pressure of a gas is decreased, its volume will increase if its temperature remains constant. So an example would be a soda can. So our formula, P1 times V1 equals P2 times V2. You don't have to write the little multiplication symbols if you don't want to. You could just put the variables next to one another. So the pressure unit, it could be any pressure unit. That should be the same on both sides. So we can't have a P1 of ATM and another one of torr. They have to be the same. And then V1 and V2 could be any volume unit. Once again, you have to be the same on both sides. Okay, so a balloon contains 30 liters of helium gas at 103 kPa. What is the volume of the helium when the balloon rises to an altitude where the pressure is only 25 kPa? Assume that the temperature remains constant. So we know P1 times V1 equals P2 times V2. And our first pressure here is 103. And our first volume is 30. Equals, we know our second pressure, we know it's 25 kPa, but we don't know our second volume. So we have 103 times 30, which would give me 3,090, which is equal to 25 V2. So how am I going to get that V2 variable by itself? I'm going to divide by 25. And I get 123.6 liters. We have one more example here, Boyle's law. So now we have a sample of neon gas, occupies a volume of 677 milliliters at 134 kPa. What is the pressure of the sample if the volume is decreased to 642 milliliters? So once again, same formula, P1 times V1, P2 times V2. It's really helpful with these gas law problems to write your formula out so you know what you're working with, what parts of the formula. So our first pressure here, 134 kPa. First volume, 677. What is the pressure of the sample? So we're looking for P2. We know our second volume, 642 milliliters. So we have 134 times 677. And I get 90,718, which is equal to 642 equals 642 P2. So divide by 642. And I get 141.31 kPa. Now the next law is called Charles's law. So at the temperature of a gas, increases, its volume will increase if the pressure remains constant. So temperature and volume are proportional. So an example of this would be a hot air balloon. So air is heated, it expands, pushing against the side of the balloons. So temperature must be in the Kelvin unit. So for our temperature, if they're going to probably give it to us in degrees Celsius, we'll have to add 273.15 to the Celsius degree that they give us temperature. And for volume, it could be in any unit. It just needs to be in the same unit on both sides of the equation. So this graph shows how the volume changes as the temperature of a gas changes. And you will do an activity dealing with Charles and Boyle's law based on two graphs, and you'll interpret those and answer a few questions. So it says a balloon inflated in a room at 24 degrees Celsius has a volume of 4 liters. The balloon is then heated to a temperature of 58 degrees Celsius. What is the new volume if the pressure remains constant? So we know our formula, V1 over T1 equals V2 over T2. So our first volume, 4 liters, all over 24 plus 273.15, and we'll get 297.15 equals, just what's the new volume? So we have V2 all over 58 plus 273.15, which is 331.15. So we need to cross multiply and divide. So 331.15 times 4 will give us 1,324.6, which is equal to 297.15 V2. We know to get V2 by itself, we need to divide by 297.15. Write that again. And our answer would be around 4.46 liters. In our last example here, we have what is the temperature of a 2.3 liter balloon if it shrinks to a volume of 0.632 liters when it is dipped into liquid nitrogen at a temperature of 77 Kelvin. So we know our formula, V1 over T1 equals V2 over T2. So if we read this, right, it says, what is the temperature of a 2.3 liter balloon if it shrinks to a volume of 0.632 when it is dipped into liquid nitrogen at a temperature of 77 Kelvin? So let's see. We know our first volume, which is right here, 2.3 liters. But in this case, we're looking for T1. They don't tell us what that is. We know V2, which is 0.632, and they tell us that that is 77 Kelvin. Okay, so once again, we have to cross multiply and divide. So we have 2.3 times 77, which is 177.1 equals 0.632 T1. So we need to divide by 0.632. we should get 280.22 Kelvin. And this concludes our video on Boyle's and Charles's law.